A very good afternoon, all of you. So welcome to the webinar on statistics and probability for data science. My name is Vidya and I am going to be teaching you or giving you a very high level information about statistics and probability that is required for data science. So before we get started, I would like you all to go through the Edureka Masterclass page where we have all our members who are registered in this, and this is a place where you will be getting some latest courses that are available on our technologies as well as about the webinar information. So let's get started. Statistics and probability for data science. So we are going to talk about probability and introduction to probability that is required for data science, and also introduction to statistics that is required for data science. I'm sure we've all covered about probability in our school as well as in our college days, right? What is probability? It's basically a measure of how likely an event will occur. So what is that? Suppose I'm asking you to find out a probability of, if I'm going to toss a coin, what is the probability that we are going to get a head, right? So what are the total outcomes that is possible? So we have two choices, right? We have two options. One is called the head option and the other one is called the tail option. So among this head and tail, so they become part of our denominator. So that means these are the sample spaces that we have. The total options that we have when you toss a coin are two. So what is the probability of getting a head? You only have two choices, head and a tail. So the probability of getting a head is 1. So that means it is 1 by 2. So this is how we work on probability. The next is, let's understand some terminologies that is used in probability. So we have something called sample space, the one I just mentioned. What are all the possible outcomes that you can get when you toss a coin? You have only two possible outcomes called head and tail. So that is your sample space. What is your sample space when you're going to toss a dice? So what are the options you have? You have 6 options. So your denominator is going to be 6. That is your sample. What is random experiment? An experiment or a process for which the outcome cannot be predicted with clarity. So you cannot tell what is going to happen or what would be the number when you're going to toss a coin or when you're going to put a dice, right? So that is called a random experiment. An event. An event is nothing but one or more outcomes of the experiment. So if I say, what is the probability of getting a 5? So getting a 5 is basically an event that is going to happen among all the sample spaces I have. I have 6 sample spaces for a coin, and getting the chance of getting a 5 is 1. So the probability is 1 by 6. So that is a event. So let's move to our next slide. What are the different types of probabilities? We have a couple of types of probabilities called as joint probability and disjoint probability. Joint probabilities are joint events are events which has something in common. So I'm going to say a student who can get 100 marks in statistics and 100 marks in probability. Can this event happen at the same time for a particular student? Yes, it can happen. That is called as joint probability. Another example I can give you is, if I'm asking you to find in a deck of cards, if I'm asking you to get A and number 4, red, and a 4. So can you get a red and a 4 on the same card? Yes, you can get. So that is called as joint probability. What is disjoint? These two things can never happen at the same time. I want a card to be A and a 4. That will never happen. A card can either be a or it can be a 4. So this is not possible. So these are called as disjoint events. So we just discussed about the different types of probabilities. We do have something called as probability distribution. So what is probability distribution? We have something called as probability density function. It is actually called as PDF, or also called it as a PMF. We have normal distribution and we also have central limit theorem. So let's get into it and see what these mean. So what is this probability, or called as a PDF? So what is this PDF? Probability distribution function. So here, so this is going to be, this is our graph. This is our normal curve. So what is normal curve? I'll explain in our next slide. This is our graph, right? So here in this normal curve, what is the area bounded by the density function, and x-axis is equal to 1. So the probability that a random variable assumes a value between a and b and is equal to the area under the PDF bounded by a and b. So here, what is this range of data? What is this data here? What is the data between this particular range? For example, let's assume that I'm going to give you this graph is plotted for the marks of the students. We have a student who's got 95 marks here. I have a student who's got, say, 20 marks here. The least is 20, the highest is 95. And here we were going to have marks, let's say, in the range of 45 to 75. So if you see, the majority of the people are lying in this average range. So if I ask you to find out this particular range of data, A to B, that is called as a probability density function. The higher values of 95 or 90 or any higher values will be on the rightmost side, and lower values, people who are getting least marks, will also be on the lower side with minimal population. The maximum number of people are going to be in the average range. So this is actually called as a normal distribution curve. Okay, so what is probability normal distribution? The one I just mentioned is our normal distribution. So here we are going to say the random variable x. So the probability distribution that associates some variable, a variable that is random, with a cumulative probability. The formula for our normal distribution is 1 divided by sigma multiplied by square root of 2 pi times e to the power of x minus mu by 2 sigma squared. The formula may sound slightly confusing, but let me explain what these terms mean here. So here we have our x. X is our random variable. What is mu? For any data, I need to find out something called mu. Mu is going to be the mean. Next is sigma. Sigma is my standard deviation. I'm going to give you an example of mean and standard deviation in our upcoming slide. So for any data, so where I give you an example of the person's mark in the range of 20 to 95, we do have other students whose marks are plotted out here. Some students' mark is here, a student has got marks here, a few more students have got marks here, and so on. So now this is our mu. So this is your average mark. For example, let's say the average mark is 65. Average mark is 65. There are students in the range of, let's say, 45 to 75. What is this sigma here? Sigma indicates standard deviation. How far is the data away from the mean? Let's say we have a student who's got 75. How far is this 75 away from the mean? It is 10 units away from the mean. If it is going to be 10 units here, it has to be 10 units here as well. That means this is going to be a range of, say, 55 to 75. So this is sigma. Sigma means standard deviation. That is one standard deviation away from the mean. So this entire range is one standard deviation away from the mean. So we do have 2 standard deviation and 3 standard deviation as well. So you go 2 standard deviation on the right and 2 standard deviation on the left. We're going to get the next value called as mu plus 2 sigma. So this is mu minus 2 sigma, because in a normal distribution curve, we expect it to be, we assume that the values are going to be symmetric. So this, both sides, the left side and the right side, would be symmetric. So here we have mu plus 2 sigma. Here it is mu minus 2 sigma. How much is this particular value away from the mean? How much is this particular value away from the mean? That is called as mu plus 2 sigma or mu plus sigma. How much deviation do we have from your average value? Right? So for a normal random variable, we usually assume that the mean is going to be at 0 and variance is equal to 1. So that is why we have mu plus sigma or mu plus 2 sigma and the other values. So here we have the mean, which is going to determine the location of the center of the graph. And the standard deviation determines the height of the graph. So how far is the standard deviation? Do we have too much deviation in our data, or do we have minimal deviation in our data? So if you look at this, both are normal distribution curve. Both are normally distributed, having the same, both are symmetric. If your standard deviation is large, the curve kind of gets elongated. Suppose our mean here is say 10 and I have a standard deviation of, let's say, 4 units. So that means I'm going to have 14 on this side and 6 on this side. So this is how my data is going to be. But if my standard deviation is small, I'm going to have 10 here and I have only 2 standard deviations. So that means I'm talking about a range of 8 to 12. My curve will look taller and narrower, right? So these are some of the measures of central tendency. So we will see that in the upcoming slides. And we have something called as central limit theorem. So what is this central limit theorem? Before we move into central limit theorem, I need to explain some more terms on statistics. So let me complete that and get back to central limit theorem. We have probability. Different types of probability is marginal probability, joint probability, and conditional probability. Joint probability is something we've already seen. So let's see what is marginal probability and conditional probability. Marginal probability is our basic probability. So it is a probability of occurrence of a single event. So here we are checking what is the probability of getting this particular card. It is 3 and heart. So we have a total of 52. We have a deck of 52 cards. And what is the probability that we are going to get this value? So we are going to express it as probability of A is sigma I equal to 1 to K P of xi. So if I'm very particular, I want a 3 and a heart, then it is going to be 1 by 52. If we want only a heart here, then it is going to be 4 by 52, right? The next is joint probability. So joint probability is a measure of 2 events happening at the same time. So here we actually want a card, the probability that a card is an ace and a heart. So how many cards are going to be ace and a heart? So we have a total of 13 heart cards, and out of which one is ace. So it is going to be 1 by 52. What is conditional probability? So conditional probability means a probability of an event is depending on an event that has already happened. So let me give you an example. If I ask, what is the probability of play? Suppose if I'm asking, what is the probability that you're going to go out and play now? The answer is 1 by 2, because you may play or you may not play. So the probability is 1 by 2. So this conditional probability, the value or the probability value increases based on a prior event that has happened. What is that? The probability, we are basically trying to increase the chances of my probability. So I will say P of play. I have some prior event. I already know something has already happened, right? I'm going to say rain. So this is P of play given rain, right? So the given rain means it is currently raining. What is the probability that you're going to play outside? So now probably we will not say 50% chances. We probably may say 20% chance that we can actually play. This is 20 is just a random number. I'm trying to take a smaller value. So that is called as conditional probability. So here I'm going to say P of B given A. So given A means A event has already happened. Based on that, tell me what is the probability of event B happening. So if I have to link this with your joint probability, we are going to say A joint probability B divided by P of A. So this is how we are going to define a P of B given A. All right. So we just discussed about probability, and then we spoke about joint probability. Then we spoke about conditional probability, and we have something called Bayes theorem. Bayes theorem was found by a mathematician and called Bayes, and hence the name called Bayes theorem. This Bayes theorem uses this concept of conditional probability. So here I'm saying what is the chance or what is the probability of A happening given B. So B event has already happened. What is the chance? What is the probability of event A occurring? So this is actually called as posterior, which means the probability of occurrence of A given B. This is what we are trying to find out. For this, the formula, the Bayes theorem formula is probability of A divided by probability of B. So we know what is probability of event A separately. What is the probability of event B separately? Multiplied by P of B given A. So this P of B given A is referred to as likelihood ratio, which measures the probability of B given A. So we are just reversing these values out here, multiplied by P of A. P of A is nothing but the actual probability of getting a value divided by probability of B. So why do we need probability? It is going to help us optimize our model. Lot of our algorithms, mainly when you move into supervised or machine learning algorithms, they do use probability. And when you're going to calculate some laws or some how your model is performing, how is these or how are these machine learning performance, how are the machine learning models performing, then we need probability. Okay, all like I said, all our models are built out of probability. Okay guys, so now that I've just given you a brief introduction about probability, let's move on to statistics. So what is statistics? This is an area of applied mathematics concerned with data collection, analysis, interpretation, and presentation. Statistics is a really important in terms of machine learning or our data science, right? So how are you going to check? Because we need statistics because, let me explain that. So we have something called population, right? So there is something called population and there's something called sample. For example, I want, let's see, what's the example given here? Okay, suppose I want to find out what is the average age a person would live in India. Average age for all people living in India, I want to find out what could be the average age. Do you think it is possible for us to go calculate gather everyone's age and say, take all the age divided by the total number of people in India and find out the age? By then, maybe we would have lost 2 people and probably 10 new babies were born. So the moment you complete this calculation, the data is already changed. The population, that means every individual you have, the data is already changed. So whatever you average, you have actually derived is basically not correct. So it is impossible for us to perform something on population. So population is something, a collection or a set of individuals or objects or events whose properties needs to be analyzed. So we cannot work on a population. So what are we going to do? We are going to take some sample of data. So probably we will pick some sample of people across all the states, not everyone. We're going to pick some sample of people across all the states to understand their lifestyle, to understand the age, to understand how healthy they are, to understand if there is any problem in the environment which is giving them some health issues, right? That is why the age, their average age is not 70 and it is only 65 in that particular state. We're going to collect samples of data. So sample is basically a subset of my population. Probably I'm going to do some random sampling. So instead of taking everyone from here, I will probably do this. I'm going to say pick this person, I'm going to pick this, I'm going to pick this, and I'm going to pick this. One thing, before I do a sample, I should ensure that this sample that I picked is a representative of my population. I just can't go pick people from just this area and say this is my sample, right? Maybe these people belong to one state, or maybe this is a different set of data that has no relation with this data. So my data, the way I need to pick up is I need to ensure that a sample is a representative of my population. So we have different types of sampling. So let's get directly into the sampling. First one is called as random sampling. So in random sampling, you're just going to pick some people at random, and this becomes your random sample. What is systematic sample? You're going to say pick every second row of data or pick every fourth person. So this is my fourth person. This is a fourth person, fourth person, fourth person, and so on. This is called as systematic sampling. All right. Next is stratified sampling. So stratified sampling, we will, what we here do here is the subset of population should share at least one common characteristics. So we have a group of people here. We are going to take some characteristics as common. So let's consider gender. So we've already separated the male data set and a female data set. Pick a few data points from the male subset, pick a few data from the female subset, and that becomes our stratified sampling. So we do have some different types of statistics called as descriptive statistics and inferential statistics. What is descriptive statistics? Like I already told you, we already have the data with us. We already have some data with us. How are you going to transfer or understand the properties of those population? So I already have so much of data points. What are the properties of these data points? How is this data distributed? What is the average age of these people? A lot of statistical inferences we can get out of this data. That is called as descriptive statistics. So what is the next one then? So inferential statistics. So inferential statistics is what we will be using mostly in our data science, because we will not have the entire population of data. So this is your population. You're going to get only sample. So you're going to work with multiple sample data sets. So what do I mean by multiple sample data sets? Here, this inference means, can I infer something about this population using this particular sample? I'm trying to, let's say the average age of people living in India is, let's say 73 years. Can my sample get me this age which is closer to 73? Maybe my sample will not give me 73. It says, let's say 71.8, right? Or it can even say 74.2. It may not be closer to, it's not exactly 73, but am I able to get some range which is actually closer to my population mean? This is my mean, population mean, and this is my sample mean. Am I anywhere closer to this particular mean is what we are going to infer. That is called as inferential statistics. So here I'm going to draw a conclusion about my population from my sample. Okay, so we need to do a lot of tests and understand the relation and perform some statistical tests to arrive at this particular value. So here, the descriptive statistics, we have two things called as measures of central tendency and measures of variability. What is measures of central tendency? We have mean, median, and mode. We are talking about the population data that you already have. For this particular data, I'm going to calculate my mean, median, and mode. How are you going to calculate your mean, median, and mode? We will just see that with an example. Next is measures of variability. We can also call this as measures of dispersion. How is the data spread? We've already found the mean, the median, and the mode. How is the data spread? So now my data is spread like this, right? How is my spread of data? So my data is basically spreading from this side to this side, or my data is just so compact, but my spread is narrow. So my range is only so much. So this is called the spread of data. So we do have certain things called range, interquartile range, variance, and standard deviations. That is the measures that is used to understand the spread of data. So here, I'm sure you already know what is, how do you calculate the mean of a value, right? Mean is basically average. So in this example, we are just taking this particular column called HP. This is called as a cars data set. And here we've taken the HP value, horsepower, 110, 110, 93, 96. How do you calculate the average? Add all these values divided by the total number of rows, which is 8, and you get the average of 103. This is called as the mean. How do we find out the median? For median, we need to find out, it is basically the measure of central value. one thing you have to remember in median is the data should be sorted either in ascending or in descending order. Here we have taken the miles per gallon, miles per gallon for the car. So we have 21, 21, 21.3, 23, and so on. First, sort the data in ascending or descending order and take the middle value. If you have odd number of values, then the middle value will be your median. If you have even number of values, in our case, we have 8 values, then you have to take the middle representative, the 2 values here. You're going to find the average of those two. So add these 2 values and divided by 2, that would be the median. What is mode? Mode is nothing but the frequency. How many times is this particular value occurring? In cylinder, if you see, we have 6 cylinder and we have 4 cylinder. What is occurring more times? 6 cylinder is occurring more times. So we are going to say 6 is our mode. The next comes to measures of spread. What is range? Range is basically your maximum value minus the minimum value. The example I gave you, I had a student whose the lowest mark was 20 and we had the highest mark is 95. The range is nothing but 95 minus 20, which is 75. So we have data spread across 75 points or 75 units. That's called as spread of data. What is mode? Mode is nothing but frequency. Mode is nothing but frequency. Suppose I have, let's say, these are my marks, okay? 95, 93, 95, 94, okay? Now, if you look at, these are the marks of 5 students, okay? Which mark is occurring more times? 3 students have got 95. This mark 95 is your mode, okay? Median, I'll show you the previous slide. Let me show you the previous slide. Yeah. So median is basically the central value. Okay. So now if you see, you have some values here, 21, 21, 21.3, and so on, right? If this is odd number of values, let's say I'm going to give you something like this, 1, 2, 3, 4, 5. I have 5 data points. The middle value, there are 5 data points, right? Just take the middle value. This is your median. If I give you even number of values, I'm giving you 6 data points, then you need to take the middle 2 values and find the average. So the average is 3 plus 4 divided by 2, which is say 3.5. So let's see something called as interquartile range. What is interquartile range? Here I am going to divide my data into 5 different units. So what I mean here is I have some data points here, right? I have data points here. This is my minimum value. This is my maximum value. I'm sure you know how to find out minimum and maximum. And you also know what is your median value. Median is that 50 percentile, right? Apart from this, I'm also going to find out something called as 25th percentile and 75th percentile. How many people, let's assume that these are the marks, say this is 0, this is say 100, maximum mark. So this is 0, this is 100, I have 50, I have 25 and 75. So this is called as interquartile range, that middle 50% of the data. So you will have 50% of data in this range, you have 25% here and you have 25% here. Clear? So this is called as interquartile range. I'm going to divide it into quarters. Say 5 sets of values I have here. So this is 0 to 25. This is 25 to 50. This is 50 to 75. This is 75 to 100. How many people have got above 75 percentage of marks? How many people or how many students have got less than 25 percentile? So this is where we use the interquartile range. So that is your interquartile range. The next is standard deviation. So what is standard deviation? I told you it is the spread of data. So variance is first, let's look at variance. Here we have how much is our data differing from your expected value. I wanted age of say 73. I got a value of, let's say, 72. How much is this 72 differing from this value, or how is your data spread, is called as variance and standard deviation. Variance is nothing but it is called as S squared. If I do a square root of this, then I'm going to get my standard deviation. This is my actual value minus X bar. So this X bar is my 73, and this is the value that I got divided by your total number of data points. I need to do this for every data point. Let's say I have 100 data points. I need to repeat this for 100 data points and square root this, or let's say this is your variance, and I'm going to square root my variance to get standard deviation. Okay, so here I have my variance, and square root of that variance is called as your standard deviation. So it's a measure of dispersion of a set of data from its mean. How is the spread of data? So here I have some example to calculate my standard deviation and your mean. So you know how to calculate the mean, right? We have a list of numbers here. Add all the numbers, divide by the count, you're going to get 20, which is 20 data points. Add all these values and divided by 20, you're going to get a mean value of 7. 7 is the mean or the average of all these values. All right. So standard deviation, I need to apply it to the formula. What formula do we need to apply? Xi. I already know Xi is going to be 7, right? So I'm going to do this calculation for each of my data point. So these are my data points here. Mu is 7, right? Xi is 9 and mu is 7. So I need to do this for each of the data point. So for this data point, we have 9 minus 7. Then I have 2 minus 7. Then I have 5 minus 7, 4 minus 7, and so on. I need to square all these terms. I'm going to get some value here. I need to add all that value and find the average. So this is how I'm going to calculate my standard deviation. All right. So let me quickly show you a code, guys. So this is how we will be working this in our Python. So here I have just imported a basic library called NumPy. It is called as numerical Python. I've just given an alias called NP. The values that you just saw, I've just taken it as a array into a variable called as X. All I have to do here is I will say X dot mean, and I'm going to get the mean value, and X dot std, where I'm going to get my standard deviation. Now if I want my variance, then I will have to multiply or square this value. So this is my variance. So when it comes to Python, coding is pretty simple, although we just have to understand what this mean and standard deviation does. All right, guys. So this is the exact data that we had there. All right. So here, this was our standard deviation 2.9, and here also you got the standard deviation of 2.9. So the next thing we are going to talk about is information gain. So this is some common terms that we will be talking about: information gain, purity, impurity. So we have a formula for that. The formula, like I told you, right? We are going to use a lot of probability in that, right? So we're going to use a probability. So the formula to calculate entropy is pi log pi. What is this pi log pi? I'm going to find out. Let's say I have two sets of values. I have some circles and I have some, let's say, star. First, these are two different sets of data. I need to find out the probability of this set, only the circles. I need to find out the probability of only the stars. So I need to do probability of, say, the dot multiplied by log of pi. This is just a formula, guys. You just have to know the calculation. Once you get into the Jupyter notebook or your code, it's going to be with one line of code. Then I need to find out P of star, probability of star, multiplied by P of star, right? When you multiply, when you do a log value, you will get a negative value. So to negate this whole thing, we are going to put a minus sign. This becomes our entropy formula. So what is this entropy formula? What is this information gain? Just let's see with an example. Now the question is, I have a data. In that data, let's try to concentrate on one, and you should be able to understand the others. So we have something called outlook. In that outlook, we have three values. One is sunny, overcast, rainy. Windy has two choices, false and true. Humidity has two values, high and normal. And similarly, the last column. The question is, how do I have to split my data? Why do you have to split your data? We need to split so you're able to group the data, because we are talking about a huge data set, right? So now we have to do something called as information gain, calculate something called information gain. What is that? Outlook. How many data points do you have in, let's talk about windy, guys. This is a small example. How many data points do you have in windy? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have a total of 14 data points. 8 data points went to the false side and 6 data points came to my true side, right? So what is the formula for windy? So I have 8 data points here and 4 data points here. So here you have only two values, right? One is called as the yes, the other one is called no. So we need to find out the probability of yes. What is probability of yes? It is going to be 6 by 8. What is probability of no? It is 2 by 8. So we are going to apply this onto our formula. Remember that formula where I said pi log pi? That is the formula. You're going to apply it for the yes separately and the no separately. So here you see 6 by 8 log 6 by 8 plus 2 by 8 log 2 by 8. This is your yes class and this is your no class. And what is this set of value? This is for these values here. Here you have 3 by, so yes is your 3 by 3, 3 by 6, and no is also your 3 by 6. So we've applied it here. What is this 8 by 14? This is called weighted average. I have a total number of 8 data points here. I have a total number of 6 data points here out of 14. So I don't want to blindly just take the probability value. I will take the weighted average, which is nothing but 8 false values divided by total of 14 multiplied by this entropy that we just calculated plus 6 by 14 multiplied by this value. So I've got a value of 0.048. This is only for windy. We need to calculate the same thing for outlook as well. So once you calculate, you get a value of 0.247. Here, if you notice, you have 3 sets of values. So you need to do calculation thrice. So you have calculation 1, calculation 2, and calculation 3. The next is humidity. So you have to do the calculation twice here. And finally, you're going to do the calculation for temperature, and you have a value here. So now you're going to compare all these values, and we're going to see where do we have the gain. So the gain is 0.24, 0.048, 0.1, 0.02. Where is the gain highest? For outlook variable, we have a very high gain. So I'm going to say outlook is going to be my first feature, or I'm going to split my data based on outlook, because if I do that split, I'm going to get a good gain in my data. What is gain? There is some information that I'm capturing to be able to split my data correctly. That is called as information gain. Okay. So inferential statistics, I told you I will talk about the central limit theorem. So what central limit theorem does is I'm going to take a population and I'm going to build multiple samples. I have a sample 1, I have a sample 2, and I have a sample 3. So sample 1, sample 2, sample 3. Here I am going to get some set of values, right? Some random values went into sample 1, some random values went into sample 2, some random values went into sample 3. You may end up with salaries or you may end up with some values that are called outliers. Remember the example where I said salary was 10 and 20, but one person got a salary of 100. You may get this kind of values. But what we are saying is, for all this, if you take the average, I'm going to take the average, or you can also call it mean. I'm going to calculate my mean value here. And if I plot the mean of, let's say, S1, the mean of S2, the mean of S3, mean of S4, mean of S5, and so on, my curve will be normally distributed. If I plot it for only sample 1, maybe the data is not following this normal distribution. So I will take my different samples, and if I plot my data, then that means I'm going to say my data will be normally distributed. This is called as central limit theorem. All right. So I'm saying if I take the average of all these, or the mean of all these values, then those mean values for each of my sample will follow normal distribution. So what is this inferential statistics, guys? There are two things. One is called point estimation and interval estimation. So point estimation means I am saying the average age of people will be 73, right? How often can you give this exact value? This is exactly a value, right? How often can you give this value? Not always, probably not always, or maybe we can never give this value. So I'm going to give this particular exact point, and I'm saying this is my sample mean. I'm saying my sample mean is 73. So population's average is also going to be 73. Right? We don't really use this point estimation because there is a very high chance that your population average need not be 23. Then we come to this concept of interval estimation. For interval estimation, although you're saying the average, let's say the average age of a person is 73, I'm saying the average age I think is going to be roughly between 69 and say 76. I'm not giving you exact value. I'm going to give a range of value. So the average age of the person is going to be between 69 to 76. And how confident are you? So that is called as confidence interval. This is not a point estimation. This is interval. I'm giving you a range of values. All right, guys. So here, this is what we are talking about. Point estimation is an exact value. You calculate your sample mean and you say that could be your population mean. That need not be the case. Then comes this concept of interval estimation. So here I gave you an example of 73. Here I'm saying instead of saying 73, I'm going to give you a range. The age is somewhere between 69 to let's say 76. This 69 is called your lower confidence limit. 76 is called your upper confidence limit. All right. So there is something called as confidence interval. So what is this confidence interval? I'm not giving you a point. I'm giving you an interval. And how confident are you? How confident are we to give that estimate? For example, I am saying this is your normal distribution curve. This range, this area, the shaded area is actually 90%. All right, so totally it is 100%. So I'm going to give a range here. I'm going to give a value for this and this, and I'm going to say I am 90% confident that the age of the average age of a person in India is between 69 to 76. When I give 73, it is very difficult for me to give that point estimate. So I give a range estimate. All right. So how confident am I saying that people are going, this is the average age? I am 90% confident, right? So this is my 90% confidence value. And what will be the remaining value, guys? What will be this remaining value? So this is my curve. This is totally 100. And I'm saying this range is 90. That means these ranges put together should be 10%, right? So if both this put together is 10%, then this area is going to be 5% and this is going to be my 5%, right? So we're going to use these to give a proper range. This 90% confidence, by default, we actually have it as 95% confidence interval, right? So this is how we actually define. But if we are very particular, we can always change this confidence interval level. Okay, guys? So let's conclude our session. Thank you, guys.